right, so the next part is just practicing some of the properties of logs. This is a way to get logs to look different than what they do when you first look at them. So if they look super complicated, there might be a property of logs that helps to make them look a little bit simpler. So in the first ones, we're going to talk about some of the expansion properties. Those are the ones in the top row. So this is expand and contract. So when you expand, you want to make the equation look longer and flatter. That means anything that's up in the exponent spot, you want to move down to the front, right? And anything that was a multiply or divide, you want to spread out and make it an add or a subtract problem. So taking a look at what we have for those properties, the first one is how to work with a power in the log form. So when we have something on the power of the base number, it is the same thing as just multiplying the whole log by that same number. So if you don't want a power on the ending, you can move it to the front. Now, it can't be the whole log being squared. It only has to be the stuff after log being squared. So look at example 1. We've got a 6 at the end. So instead, I could just call this 6 log of 5. And that would be in its expanded form because we flattened it and made it a little bit longer that way, right? In the second one, notice that in our second example, we have a 3 times an x. So that's going to fall under this plan, and we're going to be expanding it to look like this instead. So 1 log with a base that has 2 items being multiplied together. Now these could be 2 factors. If I put 6, you could do a 2 and a 3. If it's an x and a y, the x and the y. We have a 3 and an x. So these are going to work out to be an ln of a 3, an ln of an x. So they each get their own log. And then you're going to put a plus sign. Okay, so in expanded, they each get their own. In condensed, the opposite form that it originally started in, it only has 1 log word, 1 ln, and then the things get condensed or squished together. All right, and then our last one, if we have a divide problem, it works very similarly. So we have a 1 and an x. So I'm going to move these out so they each get their own. So it looks like that. And then if it was originally 1 log with a divide, these are going to turn into minuses. Okay, and then anytime you're doing this, whether you're expanding or whether you're condensing, anytime you see any of those identities, you're supposed to take care of them. So if you saw ln of e, you're supposed to turn it into 1. Log 1 is really a 0. So this is just going to turn into negative log of x. All right, let's try a couple more. So in this one, they've already moved the power to the front, or it's always been there, we don't know. But the 16, I could probably turn that into a whole bunch of stuff, right? I could call it 8 and 2 and expand it that way. Ooh, if I call it 4 times 2 times 2, I could have 3 logs expanded, or I could do it all as logs of 2, right? Okay, so there's a lot of different ways to expand these. For our purposes, we're just going to basically say take whatever you see, try to get into a single base if you can, and then work on it from there. So I'm going to call this 1/2 of log of 2 to the 4th. Okay, now then I can use that power rule that says that 4 should go to the front, and if the 4 goes to the front, I'll just have 2 log of 2, and that's really as expanded as I could get it. I could be super obnoxious, and I could call this log of 2 plus log of 2 plus log of 2 plus log of 2 all over 2's from the 1/2 in front. That would be super annoying. Okay, that's like overkill. You could go all the way out to log 1's and put a billion of them on there. All right, so really just try to work with the numbers you have there and work on the bases. All right, in our last one, we have a 3 in front, and then we have that 5 and the 4 that we can separate them out. So we're going to get a 3 ln of 5. Then leave a space, then we're going to have a 3 ln of 4, and we're going to have a minus sign in between them, and that's as expanded as we can get. Okay. In condensing, we're doing the exact opposite. We're looking for chances where we see more than 1 log word written, and we're trying to see if they're the same base of log, can we squish them together? And it's okay in the process of squishing them together if you have to do some powers on top. That's okay. That's condensing. Right, so let's take a look at these. These are using the exact same ones backwards. All right, so in our first one here, I can see that they're both log base 10. So I'm just going to consider it a single log, and then notice that they're being subtracted. So this is going to be 8 over 4, also known as log of 2. All right, this one has an ln here and an ln here. So for sure I can make them divided by, but again, I've got a 1/2 in front. Let's move that back and make it a square root, right? If it's 1/2 power, then, and same deal here. So let's call this ln of 3 squared minus ln of 81 to the 1/2 power. So this is going to be ln of 3 squared minus ln of square root of, right, 81, which is 9. Okay, so now I could condense them together and say it is ln of 3 squared over 9, or I could have done the 3 squared first, right? And then if I look at it like this would be ln of 1, and ln of 1 is 0. If you are still working on this one, you could have called it ln of 9 minus ln of 9. Something minus itself, still 0. Okay, so lots of ways to condense. All right, so number 8, again, work on putting those powers up first, then work on condensing it to 1 log. So this 20 is going to be a power of the x, this 5 is going to be a power of the y, this 2 is going to be a power of the z. They're all same log, log base 3. So I'm going to write that out first. So it's going to be log base 3 of x to the 20th plus log base 3 of y to the 5th minus log, hello, come back, log base 3 of z squared. All right, now this one has 3 logs. We're going to condense all 3 together as one single log base 3. And I'm just going to create a fraction bar with room on top and room on the bottom. Anything that's added is multiplied on top. Anything that's subtracted would be multiplied on the bottom. So this would have an x to the 20th and a y to the 5th and a z squared. And we would just leave it like that. Okay, so that would be condensed.